Hello everyone, Namaskar. In today's lecture, we will discuss about carbonated fruit juices and premixes. The topics which we will discuss include carbonation, how do we do carbonation, why do we do carbonation. We will also discuss about de-aerators and carbonators, then soft drinks and its composition, fruit material and nutraceutical as ingredients in these beverages, process for the preparation of carbonated food beverage, and finally, we will take up one case study, that is the carbonated amla beverage premix. So, what is carbonation? It is a process to dissolve a quantity of carbonic gas into different products. The product may be water, wine, juices, soft drinks, etc. And the purpose here is to obtain a gasified or carbonated final product. When dissolved in water, carbon dioxide is sparingly soluble in water, and thus it gets slowly released and forms bubble that provide a characteristic mouthfeel and unique taste when these carbonated beverages are consumed or carbonated products are consumed. The benefits of carbonation include that it helps to protect the aroma and color as well as to increase the tasting smell. It under suitable conditions, the carbon dioxide has a preserving property. It inhibits the development of harmful aerobic microorganisms. Drinking carbonated cola drinks may harm bone health, but plain sparkling water appears to have a neutral or positive effect. A carbonated drink may even enhance digestion by improving swallowing ability and reducing constipation. And why CO2? The CO2 gas content is one of the smallest constituents by weight, maybe it is about 7 gram per liter, but possibly the most important in regard to palatability of the product. CO2 is one of the very few gases which are suitable for providing the effervescence in soft drinks. You can see in these bottles, that carbonated drink in bottle at a high pressure, how the CO2 is there, and then when the pressure is released, then this CO2 is evolved in the form of bubbles. CO2 is a non-toxic gas, it is inert, it is tasteless, and it allows for convenient bulk transportation and storage. Now, how can we do the carbonation? How can the beverages be carbonated? There may be impregnation of a liquid solid with CO2 gas from carbonic acid. Okay. The carbon dioxide was traditionally obtained from the lime kilns, that is by heating the calcium carbonate, and the calcium carbonate, when it is heated, the carbon dioxide gas is generated, this is collected, and this can be then used for the carbonation of the beverage. Okay. Now, it has been replaced by carbon dioxide stored in pressurized insulated tanks, which are kept at low temperature. So, this purging of carbon dioxide gas into the beverage is another method. Even for the use in the juice powders, a carbonation powder premix can be formulated and developed from the mixture of acids such as citric acid, tartaric acid, and base component, which is sodium bicarbonate. And this carbonation mixture or carbonation powder can be mixed with the fruit juice powder, etc., and when dissolved, it will give the carbon dioxide gas effect in the beverage. Carbonators combines carbon dioxide gas with the liquid to be carbonated. Carbonators are classified into two categories, one which is used to carbonate water only, and the other is the which carbonate the finished product, that is maybe syrup flavor mixture or syrup water mixture. So, depending upon the specific beverage being produced, the carbonator is regulated, so that the water will contain or beverage will contain about 1 to 5 volume of gas, and 1 volume of gas is equivalent to 15 pound per square inch pressure at sea level and at 15 degrees Celsius temperature. So, soft drinks accordingly may contain from 15 to 75 pounds of per square inch of gas pressure. Okay. Now, let us see that these most of the carbonator plants, they need to install one de-aerator, that is the oxygen amount may be removed. Beer, cider, wine, they have naturally some dissolved carbon dioxide in them. Their only need is to boost CO2 when carbonating, but in the soft drinks and water, the condition is little different. Water is naturally rich in atmospheric oxygen, which needs to be removed before the carbon dioxide is added into it. Otherwise, what will happen? The water will not be saturated correctly and will reject the carbon dioxide, causing low carbonation feel on the palate. Moreover, immediately as a bottle is opened, the fizz will disperse rapidly if oxygen is present, causing the water to drink to go flat. For this reason, before carbonating water for preparation of carbonated soft drinks, it is necessary to use a separate de-aerating unit to remove the oxygen from the beverage. Now, there are different methods of measuring the carbonation. Okay. It may be either on the measurement of volumes or grams per liter. 1 volume means 1 liter of carbon dioxide in 1 liter of drink, that is about approximately 2 gram per liter. Most carbonated drinks contain 3 to 4 volumes, there may be 6 to 8 gram per liter of carbon dioxide. Okay. Carbonation is usually determined by measuring the pressure in the container at a known temperature. The pressure inside a container depends on the level of the dissolved carbon dioxide and the temperature. The solubility of the carbon dioxide in the liquid depends upon the pressure and the temperature of the liquid while it is being solubilized or while it is being carbonated. The standard instrument used by the soft drink industry for measurement of carbonation is a jam CO2 tester. You can see here in the figure. Another method is sniff method, where the pressure is released initially, that is sniffed, to flush air out of the head space. The pipe is then shaken and the maximum pressure is noted. Colorimetric methods are also available, but they are not used as they are prone to interference in strongly colored soft drinks. The color of the beverage may interfere with the measurement. Okay. FSSAI has finalized the standards for carbonated fruit juices and fruit drinks in the year 2011, and those are given here, but in 2016. To enhance the carbonated fruit drinks, FSSAI added another type of formulation, that is they revised their earlier guidelines. So, as per the guideline, as per the 2011 regulation, total soluble solids mass by mass, it should not be less than 10%, but it is not applicable as per the modified regulations of 2016. Fruit content mass by mass in the beverage should not be less than 10% as per the earlier regulation. In the 2016 it was if less than 10%. Then lemon content not less than 5% by earlier regulation of 2011 and not less than 2.5% in the modified regulations. Other fruits not less than 10% as per the 2011 regulation and not less than 5% as per the 2016 regulation. Now, here in this table I have given the ingredients in a carbonated beverage. In the sparkling water, where In the water, only sodium bicarbonate to the tune of 300 to 400 ppm it is added, and otherwise it has no color, no acid added into it, and carbon dioxide volume of gas is around 4 to 5. In the ginger ale, the flavoring component is ginger root, oil and lime oil. Caramel is the color, citric acid is the preservative which is used, and then volume of the gas is around 3. In the orange beverages, oil of orange and orange juice are normally used as flavorings, and then tetragen for coloring purposes and citric acid. The carbon dioxide volume is 1.5 to 2.5. In the grape beverage, methyl anthranilate and oil of cognac grape juice added sometimes, flu FCF color, and the tartaric acid is permitted, and 1 to 2.5 is the carbon dioxide volume of gas. Similarly, lemon and lime data is also, they contain either lime juice, oil of lemon, lemon juice, tartarine, or even in the lime none of them are added. Citric acid is the acid, and in the lemon beverage maybe 1.5 per volume of the CO2 gas, but the lime it contains around 4 to 4.5 volume of the gas. Okay. Now, soft drinks, that is the major ingredients of the soft drink are water, flavor emulsion and emulsifier, coloring agents, sweeteners maybe sugar and sugar substitute, acids and preservatives, and carbon dioxide. So, a quality soft drink should have a balanced blend of flavor at proper intensity, leaving a clean mouth taste with no lingering flavor or unpleasant aftertaste, and it should have a proper carbonation to impart zest and sparkle to the beverage or sparkle to the drink. Okay. So, the ingredients we will study about the individual ingredient, particularly their characteristics and quality. So, first is the major ingredient, main component of any beverage, in the carbonated beverage or in the soft drink, it is the water. Okay. So, the quality of water used to manufacture the soft drink is of prime importance, and much attention is given to its treatment and to its behavior, particularly in relation to the other constituents, flavoring, etc., and other things, how this water behaves with them, how it interacts with them. Okay, that is taken, and particularly the constituents, if they are in the water, okay, either soluble salts or other constituents, they may interfere with. So, the water which may be satisfactory for household drinking, it may not be suitable for soft drink manufacturing. So, the most of the soft drink manufacturing plants, they are provided with, they have their water treatment units, okay, and the water is treated for the removal of any unstable iron by oxidation or by flocculation. It is removed, that is any sediments, etc., are removed by sand filtration. Okay. Water is made soft by ion exchange, it is sterilized by the addition of chlorine gas, it is filtered through active carbon, are treated with UV light at the end finally. So, extra pure quality of the water which does not have any suspended, dissolved or colloidally particles or salts, etc., that is used for the beverage manufacture. The flavorings, it can imparted by the fruit juice and our essence, they are comparatively smaller components, and when we are talking about fruit beverages, carbonated fruit beverages, in fact it is the fruit juice or fruit pulp which is used as a flavoring agent. So, majority of the soft drinks are flavored by synthetic flavoring materials, maybe solution of some natural extract, or most likely sometime a mixture of both. Isopropyl alcohol is generally used for extracting the essence or in the synthetic essence. When such essences are used in clean products such as lemonade, it does not produce any clouds, and preparation is suitable for use as flavoring material for soft drinks. So, factors affecting the flavorings include type of water and degree of carbonation used, the sweeteners and extra acid added, also play important role. Even some flavors are kept associated with special acids. Okay. That is, these flavors, even their flavoring potential is boosted in the presence of certain acids, etc. Okay. So, commonly used acids for flavor include the tartaric acid, okay, that is most common. It gives citric acid, and even tartaric acid also gives different flavor. Likewise, cola, they use phosphoric acid, and glucose syrup drink. Glucose syrup drink use lactic acid and a mixture of lactic acid and citric acid. So, other permitted acids may be malic, ascorbic, nicotinic, acetic. So, various organic acid may be used, but as I told you, that is the flavor and this acid, that they should go simultaneously, they should have good effect. So, type of flavoring which is used, it may be natural, derived from the natural sources, or nature identical, that is, which is derived from chemical synthesis, but identical to the compound found in nature. And artificial flavor, it is fully synthetic flavoring material, and it does not have any resemblance with natural substances. Coloring matter, the color decision is driven by the consumer perception of the product appearance. The use of artificial colors have been decreased significantly, as they are regarded as unacceptable by many consumers. And here again, the natural fruit juice, that is fruit juice, they have their own color. So, that is sometimes by using the fruit juice and pulp, the color is also added, but some additional colors in some beverages, that is this which matches with the color of the fruit juice or table juice, can also be added. Okay. So, this but anyway, addition of this soft color matter to a soft drink immediately creates complicated chemical problems, because these colors, most of the soft drinks, that is the synthetic colors, etc., they are blend of various chemical compounds. So, these chemical compounds particularly, they also will have interaction with the flavoring compounds, with other components. So, that has to be taken, that is all these. So, color, they should go also together with the flavor and other component, their interaction should be in positive interaction for beneficial purposes. Most of the synthetic colorings have a leucoform, and which is produced by chemical reduction of the coloring matter, and this can occur when sulfur dioxide particularly is used as a preservative. So, if you are using a fruit juice, fruit pulp, and particularly if sulfur dioxide is used as a preservative, then many complex reactions may occur with these sulfur dioxide and fruit component and even the other coloring materials which are used. Some of the permitted colors are given here in this table. Then sweeteners in a soft drink is contributed either by sugar or by an artificial sweeteners. In the soft drink regulation, sugar means any soluble carbohydrate sweetening matter. The sugar has a far wider implication than just sucrose. And although this is commonly used sweetening material, sucrose is most commonly used sweetening material, but the other compounds such as glucose syrup, fructose and invert sugars are also becoming more and more popular slowly and slowly. So, process control during the blending and bottling operation is usually monitored by Brix measurement. Okay. Thus, the blending of a syrup and water will require recalibrating. Inversion of sugar, that is inversion means that is decomposition, hydrolysis of sucrose into glucose and fructose. It will cause the Brix of the bottling syrup to slowly increase, maybe by up to 5% on the prolonged standing, especially if the syrup is warm. So, these should properly be taken care of. Artificial sweeteners like use of cyclamates as sweeteners caused a surge of reformulation of soft drinks in which sucrose were partially substituted either by cyclamate or saccharin or by mixture of both. When the use of cyclamates was banned, formulators had to fall back on the use of saccharin alone. Today, the only legally permitted artificial sweeteners in the form of saccharin calcium and saccharin sodium are allowed. It is usual to use a mixture of sugar and saccharin in soft drinks, and the legal limits for each of them are clearly regulated in the country's regulation. Okay. Aspartame is a low calorie artificial sweetener that is 200 times as sweet as natural sugar. Aspartame is recommended by FSSAI for use in soft drink with a maximum limit of 700 ppm. The permitted preservatives are given here in this table, like if the soft drinks, which is for direct consumption, that is consumption after dilution, okay, not otherwise specified in the regulation, including the comminuted citrus bases for the preparation of soft drinks. There benzoic sulfur dioxide 350 ppm, benzoic acid 800 ppm, methyl 4-hydroxybenzoate 800 ppm, and ethyl 4-hydroxybenzoate and propyl 4-hydroxybenzoate both. So, only sulfur dioxide 300 ppm and other are 800 ppm. So, and the categories of the soft drink, which is for consumption without any dilution, it is not otherwise specified in the schedule. There the same, the label of the preservative like sulfur dioxide label is fixed at upper limit is 70 ppm and other are 160 ppm. Okay. This is the process flow chart for soft drink manufacturing. So, in the soft drink manufacturing, normally what they do, that there are two methods. One is that a syrup is made by dissolving the sugar, and then the flavor concentrate which is made, flavor concentrate is separately made and it contains all the flavoring material, coloring components, acid, etc. So, and also the preservatives. So, the sugar syrup is made separately and then the flavor concentrate is added into it, it is dissolved and then it is diluted, and finally, that carbon dioxide is added into the diluted syrup. That is one way. Or in the other way, what they do, that this water is carbonated and then in the prepared sugar syrup and containing flavoring etc., carbonated water is added. So, there are several industries, but majority of them what they do, they prepare flavor concentrate, okay, and this flavor concentrate, its composition, most of the standard soft drink manufacturing companies are there, it is highly guarded secret. So, they produce this syrup, that is the flavor concentrate, and they give it to the various distribute it in different countries and locations where they have the carbonation facility, dilution facility, where liquid water is added as per the formulation and carbon dioxide is purged into this, the beverage is carbonated. So, the fruit materials, as I say, that is it is the flavor and color, they have they add the natural fruit drinks etc. The fruit material they may be having up two types like comminuted or comminuted fruits, that is a term reserved for citrus parts, but all of the main component like of the citrus like peel, pith, juice and peel oil etc., they are combined into a pulpy mixture and that is finally milled and then preserved, and this is used as a ingredient for mixing in the beverage. Or even the cloudy extracts, they are also specialized citrus product manufactured by extracting de-aerators peel and pulp residue with hot water with the addition of proteolytic enzymes, and the filtered cloudy liquid is then pasteurized and concentrated, and this is used as a in the beverage manufacture. So, the comminuted fruits are used for the production of whole fruit drink, or comminuted deliver more color flavor than cloud juices. Cloud than juices. Cloud extracts is often used in recipes for citrus based soft drinks to obtain a good cloud, but can introduce a slightly cooked marmalade note to the flavor. Fruit material as ingredient, that when you are adding, that is the fruit materials as ingredient either for flavoring purposes or for coloring purposes, as I told you earlier also, it has that is when you are adding natural this component in the natural fruits etc., they again the coloring and flavoring pigments are various components, various organic compounds etc. Okay, blend of compounds are there which give the characteristic flavor of a particular fruit or vegetable. So, this has some implications when this fruit juice or fruit pulp is to be used in a soft drink or in a beverage. There are certain issues which need to be resolved, like inclusion of fruit makes it more vulnerable to yeast and molds. Okay, that is, if the juice is liquid beverage is not properly pasteurized, then these yeast and molds may create problems. Even oils, especially from the citrus juice which is added as a flavoring agent etc., it may get oxidized. Solid accumulations near neck or bottle from the bottom of the bottle like squares etc., that is where that is enzyme like pectin methylesterase etc. are not inactivated. So, it causes the insolubilization of pectin and then it serum separates and it accumulates on the either bottom or the top. Then selection of proper emulsifier and stabilizer agent becomes necessary when the fruit juices are used. Often new flavor is developed by blending many flavors in order to defy imitation to remain unique. So, particularly when the enzymes in fruit preparation has not been deactivated, as I told you in the pectin methylesterase etc., or such other enzymes, they will continue to act upon the pectins and the cloud stability can be lost. So, these the cloud stabilizers and all those things has to be added into the beverages. Also, the nutraceutical or functional ingredients can be used. They are used as ingredient in drinks which are claimed to have functional benefits in addition to the being thirst quenching, and particularly when these fruits beverages, that is the one major reason why it is encouraged that the fruit juices should be added, fruit juice or pulp etc. should be added, because they contain various macronutrients etc., health promoting components. So, they are considered as nutraceutical, or the beverage will become a health beverage. So, like vitamins, minerals, antioxidants are most commonly used functional ingredients and they are found in the natural fruit vegetable juices. Vitamin A is added in soft drinks as beta carotene or provitamin A, that is, this is a precursor of vitamin A. When you consume this in the body, it is converted into vitamin A. Even B vitamins also are added frequently into the sport drink. Even the most commonly added mineral is calcium, which is associated with the bone and teeth, but other minerals such as zinc etc. are also added. Even sodium, which is the key mineral that is lost during the perspiration process, it is also added into the soft drinks. Most of the soft drinks, they have added amount of sodium. So, additives and their functions like acids and acidity regulators are used to control the pH and total acidity of a drink. Acidity is a fundamental characteristic of any soft drink. The balance between sweetness and sharpness is known as the Brix acid ratio, and it is the key parameter to the formulation of a soft drink. Anti-foaming agent, like the only permitted anti-foaming agent is dimethyl polysulfone E900. It is permitted up to 10 milligram per liter to prevent head formation or foam formation. Antioxidants in soft drink like ascorbic acid is added to protect the flavor from staleness and also to protect the color of the product. Okay. Stabilizers, that is the in cloudy fruit juices, pectin is added to increase the stability and appearance of a soft drink. Sugar provides considerable thickness and mouthfeel to a drink when it is replaced by a high intensity sweetener. The drink can lag the body in the mouth. This can be resorted or this can be restored by the use of a thickener such as pectin etc. There are also a member of the specialty gums, for example, number of specialty gums like guar gum, carob, xanthan gum etc. They can also be used as a stabilizer agent or thickening agent. Okay. This is the process flow for the fruit beverage preparation. Okay. And this is, as I told you, that is water cleaning, etc., that is water softening, then heating, evaporation and carbonation, that water is carbonated in the second stage of mixing, and third stage of mixing carbonated water is coming here, and then here it is a coloring material, syrup or flavor, and then this is a fruit juice and pulp is also added this, and then finally it is filtered, properly homogenized and sent to the packaging unit. So, this is the process flow. So, most of the, even this in the beverage unit for cleaning and all those things, lot of waste and effluent water is generated. So, this most of this beverage manufacturers, they have their waste water treatment plant in the beverage industry to optimize the water use or improve the water use efficiency. So, this is just a schematic given of a wastewater treatment, that is the collected water is taken, it is pre-screened and then sent to the equalization tank, and where that is certain chemicals etc. added, reaction tanks, and then the impurities etc. they are dissolved in this, either they are removed, as a sludge thickener tank they are removed, and it is recirculated again the sludge etc. after treatment, and the effluent is collected here. So, this is in brief wastewater. So, now I will take finally the case study, that is the amla, carbonated amla beverage premix, which was developed in my laboratory at IIT Kharagpur. You know that amla is a underutilized fruit. It is a natural source of antioxidant like vitamin C and polyphenols etc., but it is very highly astringent, and because of its bitter taste, astringent taste, it cannot be consumed as a fresh, and therefore, it is processed traditionally into various products. The carbonated amla juice helps in increasing the taste with its characteristic flavor. Okay. So, what we did in lab, we prepared amla powder, okay, and this using spray drying technology, and also separately a carbonation powder was formulated with a mixture of acidulant and sodium bicarbonate in different ratios, and these amla powder and carbonation powders were mixed together to get the carbonated amla drink. So, this is the process flow chart for the preparation of carbonated amla beverage premix. So, this amla is taken, it is blanched, okay, using either hot water or microwave. We have conducted both processes and both are good, but it has to be conditions, they have to be optimized, conditions have to be used. So, after blanching it make the soft, then the juice is extracted, and after the extraction of juice there is also some amount of this residue that is remaining after the extraction of juice, that is dried and then ground into fine powder. Okay. Also there are, we have given some instantization treatment to the powder. Okay. So, this instantized fiber powder and amla juice, these are together mixed in a particular proportion and spray dried powder is obtained. So, the spray dried amla powder and the carbonation powder, which we told that we developed separately. So, these are now both of them are mixed in a proper proportion and get the carbonated amla powder premix, and this can be dissolved in water, lukewarm water or normal water, plain water. It has a good solubility, good reconstitution, and you get a taste of feel of a very good tasty beverage. Okay. So, in the experiment when we conducted, there is various combinations and permutations were used, and the amla powder, it was varied in from 50 to 70% and carbonation powder from 30 to 50% in the range different, and just to find out what is the optimum proportion, proper proportion, which gives a good overall acceptability and other organoleptic characteristics. It was measured for the pH and sensory characteristics like color, mouth feel, aftertaste, taste, aroma, etc. And then it was found finally the sample, that is the ratio of 70:30 gave best sensory characteristics with an acceptability on the 9-point Heidelberg scale as about 8.56. The carbonated powder was found to have shelf life of about 6 months. So, 5 gram of premix, the premix which is having this amla powder or spray dried amla powder, instant amla powder, and the carbonated carbonation powder in the ratio of 70:30. So, 5 gram of that is required to prepare 100 ml of carbonated beverage, amla beverage, which contains 90 milligram of vitamin C, 0.2 gram protein, 0.2 gram fiber and 1 milligram of iron, you can see. So, it becomes a very good nutritive and refreshing beverage, okay, or it can be considered as a health beverage. Okay. So, there are when now as per the FSSAI norm and guideline it is being encouraged, then in the soft drinks the natural fruit juice should be added. So, there should be some method how to assess that, how to test that natural fruit juice has been added or not. So, there are various methods like to assess the fruit content, like the S content, nitrogen content, or even level of the minerals like potassium, phosphorus, amino acid, etc., because these are present in the fruit juice only, they are not present in the soft drink. So, their content depending, if you know that approximately how much fruit juice has been added, so one can easily find out what should be the amount of these ingredients into that, so they can be measured. So, the easiest method normally it is to add the potassium and other ions in the carbonated drink. However, the major disadvantage of this method is that if any manufacturer, particularly unscrupulous manufacturer, they want to circumvent, they can directly add potassium or other salts from outside. So, it becomes difficult that you will get in the beverage the potassium or other salts, but it will be difficult to know whether it is from the fruit juice or it has been added from outside. So, alternate methods were developed to take care of such problems, okay, and it is basically by either genome sequencing or such other methods, amino acid analysis, okay, or organic acid, that is which are specific to the specific fruit or vegetable juice. The characteristic component of the fruit juice should be used, that should be used as a marker in the beverage, that is every juice, every fruit, they have some characteristic component. So, that can be used as a marker, a parameter to evaluate the content of the presence of this particular juice in the drink. Like for example, quin acid is in cranberry, isocitric acid in orange, grape or lemons, they can be considered as a marker and they can be analyzed in the mixed juices. So, a specific marker can determine the level of a particular juice or pulp in a carbonated drink. So, that should be used. So, I will finally summarize this lecture, that yes, carbonated soft drinks, they are very important category of beverage, and normally these soft drinks which we get in the market, they do not have any nutritional value except that of the sucrose or sugar which is added as a sweetening agent, otherwise they are taken as a thirst quenching. Okay. But when if you are adding these fruits or vegetable juices, fruit juices, pulp, etc., in the beverages, so it becomes a source of micronutrient you are adding, you are increasing the nutritional value and health value, and these can be used, such carbonated beverages can be used as a health drink, as a supplement, and for nutrition purposes they can be better. But adding the natural fruit juices, pulps, as I had told you earlier, it may invite certain problems which has to be resolved, and there should be standard method for mixing, proper mixing, that is the fruit ingredient which you are taking, the ingredient that it should not be interfering with the other components in the soft drink or beverage, etc. Okay. So, the carbonated fruit drinks can be fortified based on their purpose, either by vitamins or other minerals, etc., and it can be promoted in the market as a health drink. Okay. So, these are the references. I thank you very much for your patience hearing. Thank you.